Welcome back to our math series. Today, we're going for a deep dive into something that might sound a little counterintuitive at first.
Oh,
It's about how simple math can sometimes be better at predicting things than experts.
fascinating area. Yeah, we're talking about what are called arithmetic models.
Okay.
Basically, just using addition and multiplication.
Oh,
You wouldn't think it,
yeah.
but they can be really accurate for predicting stuff in the real world.
I gotta say, I'm a bit skeptical.
Yeah.
Like, how can just adding and multiplying be better than someone's experience?
Yeah. Look.
All that knowledge. What
Yeah.
what does the research say?
So way back in 1954, there was this researcher, Paul Meehl,
Okay.
and he published this book called Clinical versus Statistical Prediction, and it was really groundbreaking. He basically said that lots of real-world events,
Oh.
even really complicated ones,
Mm-hmm.
could be predicted pretty well just using these simple arithmetic models.
So not just like theoretical math problems, but
Yeah.
like actual stuff out in the world.
Ex-
Can you give me some examples? What kind of things were they predicting?
Yeah, so Meehl's research and then tons of studies after that
Okay.
have shown this works across a bunch of different areas,
Okay.
like predicting students' GPAs,
Ah.
whether someone with schizophrenia will get better,
Wow.
even things like how many criminals will reoffend, or like how successful Navy training programs will be.
That's wild. Okay, so it's versatile, but like how much better are these models
Right.
than the experts? Is it a small difference or is it significant?
It's definitely significant, maybe
Yeah.
even an understatement. So there was this meta-study
Okay.
back in 2000, and they analyzed 136 different comparisons,
Oh.
all sorts of stuff, advertising, heart disease, even marital satisfaction.
Mhm.
And what they found was that, on average, the arithmetic models were about 10% more accurate than the experts.
10%. That's huge. You'd think experience or just having more information would give the experts an edge, but it sounds like that's not always true.
Exactly. And sometimes even having a ton of data, like from an interview or something, actually made the experts' LSS accurate.
Really?
Yeah, and the study found that the models were better regardless of how much experience the expert had.
So what's going on here? Why is basic arithmetic, stuff we learn in grade school, working so well in these complicated situations?
There's a few reasons for that. First, if you use models for prediction, it frees up the experts to focus on the stuff they're really good at.
Okay.
So instead of crunching numbers, they can be out there gathering data, coming up with hypotheses, or even helping to make those models better.
That makes sense. Play to their strengths, right?
Exactly.
It's like giving them a tool to use instead of expecting them to be the calculator.
Right. Plus, these models can be checked out by people who aren't experts in the field, which makes them cheaper, and the results are easier to understand. You don't always need a whole team of PhDs to figure out what the numbers are saying.
And I imagine speed is a factor too. Like in the real world, sometimes getting a quick answer is more important than a perfect one that takes forever.
Absolutely. Models are much faster than a bunch of experts sitting around debating. That can be really important when you need to make a decision quickly.
Okay, so it's efficient, objective, and surprisingly accurate. But I'm still kind of stuck on how experts make these predictions in the first place.
Okay.
Like, what are they actually doing in their heads when they have to weigh all this information?
That's a really important question, and this is where a researcher named Dawes did some really cool work.
Great.
He suggested a model to break down how experts make judgments into 3 parts.
Okay.
The first part, experts are amazing at. They pick the right variables, and they figure out if those variables are positively or negatively related to whatever they're trying to predict.
So, like, if we were trying to predict, say, whether a new business would be successful,
Okay.
an expert would know to look at things like how big the market is, how much experience the team has, and how much funding they have, right?
Exactly.
And they'd understand if each of those things makes success more or less likely.
Exactly. That part they're great at. But the second step is where it gets tricky. Assigning weights to each variable.
Weights.
Yeah, it means figuring out how important each factor is compared to the others.
So in our business example, is the team's experience more important than the market size? Or the other way around? That kind of judgment call.
Exactly. And studies have shown that even though experts are great at picking the right factors, they're not so good at figuring out how much each one really matters. It's often done way more randomly than you'd think.
So they know what to look at, but not really how much each thing matters. That seems like a big problem if you're trying to be accurate.
It is, and it's a big reason why their predictions aren't as good as the models. Now, the third part of Dawes' model adds even more complexity, something he called noise.
Noise.
Uh,
Picturing like static on a radio,
Ah.
not something to do with expert opinions.
Think of it as all the subjective stuff that gets mixed in with their judgment. Like their biases, opinions, maybe even irrelevant information that's stuck in their head. All that noise makes it harder for them to be objective, even if they don't realize it.
So even when they're trying their best,
Mm.
our brains add all this extra interpretation that's not just based on the numbers. That's where the math has the advantage, right?
Yeah.
It just sticks to the facts.
Exactly. To test this out, Dawes actually did an experiment where he asked experts to make predictions using completely random data.
Random data. I don't get it. What's the point of that?
He wanted to get rid of that noise we talked about.
Okay.
Because with random data, there's no real-world context for them to latch onto.
Right.
So they had to base their judgments purely on the relationships between the numbers.
Ah, so it's like a pure test of their ability to weigh things and make calculations.
Exactly.
No emotions or past experiences to mess things up.
Right. And what he found was that even with this meaningless data, the experts were still less accurate than simple models.
Wow, that's pretty convincing. So even when they're forced to think mathematically, our brains just aren't as good at it as the formulas themselves.
Yeah. Yeah, it really shows you how powerful those simple calculations can be.
Mm-hmm.
A lot of the complexity we think is out there in the world might actually just be in our heads, not in the numbers themselves.
This is making me rethink how we approach predictions in general.
Uh-huh.
Like we tend to overcomplicate things, trust our gut,
Mhm.
when maybe a simple objective method would be better.
Yeah.
But you mentioned something earlier, unit weights.
Yeah.
And I'm not sure I followed that part.
Oh, right. So unit weights are a way to simplify the whole weighting process even more.
What?
Instead of trying to figure out how much each variable matters,
Right.
just give them all equal weight.
Wait, so you're saying every factor is equally important? That seems way too simplistic.
Yeah,
Wouldn't that make the model less accurate?
you'd think so.
Yeah.
But it's surprising, it often doesn't. Studies have shown that these unit-weighted models can be just as good or sometimes even better than models with more complicated weighting systems.
I'm really struggling with that.
Yeah.
Why would ignoring the real differences in how much things matter lead to better predictions?
There's a couple of reasons. Remember how we talked about experts having trouble assigning accurate weights?
Yeah.
Well, even when they try to make those distinctions, they might actually be adding more error than they're fixing.
So by saying, we don't know for sure, let's just treat them all the same,
Right.
you're actually avoiding that potential pitfall of human judgment.
Exactly. And the second reason is that sometimes you just don't have enough information to figure out those complex weights,
Okay.
especially when you have lots of variables or not much historical data.
So it's a practical solution when you can't build a really fancy model because you're missing some information.
Right. In those cases, unit weights can actually be more reliable because they're not as sensitive to small changes in the data.
There's something elegant about that simplicity.
Yeah.
It's like you're saying, let's just trust the basic math, no need to overthink it.
Dawes actually put it really well.
Okay.
He said, the whole trick is to decide what variables to look at and then know how to add.
I love that.
Yeah.
It's a great reminder that the simplest solutions are often the most powerful.
Mm-hmm.
Can you give me an example? Like, how would this unit weight thing actually work in practice?
Sure. Let's say you're a small company and you're trying to hire someone who's willing to challenge the way things are done.
Okay.
Be a bit of a contrarian. That's valuable, but hard to assess in an interview.
Yeah, you can't just ask, are you a contrarian, and expect an honest answer.
Exactly. So instead of trying to read into everything they say, you could just count how many times they disagree with the interviewers.
Okay.
Not that every disagreement means they're a rebel, but it's a data point,
A potential indicator.
Right. And instead of overanalyzing each disagreement,
Yeah.
you just give them all equal weight, add them up.
So it's like saying, we don't know why they're disagreeing,
Yeah.
but the fact that they are is information.
Precisely. That simple count, along with other relevant factors, might actually give you a pretty good prediction of whether someone's likely to shake things up once they're on the team.
That's pretty clever. You're taking something subjective, this whole contrarian idea,
Right.
and turning it into something you can actually measure and use in a model.
That's the power of unit weights.
Yeah.
They let you create models that are simple but still really robust.
Okay, I'm starting to see why they're useful.
Yeah.
But even if these models are better than just guessing,
Mm-hmm.
they're not perfect, are they?
Of course not. No model is perfect. But what's interesting is that the limitations of these models
Yeah.
often show us just how hard prediction really is,
Okay.
which is something experts might try to hide with their
It's like
confidence.
the model saying, look, this is the best we can do, and it's still not that great, which means this is just a really tough problem to solve.
Exactly. The fact that the model's limitations are so clear can help us be more realistic about what we can and can't predict. It's not about saying arithmetic is always right, but that it often does a better job than we give it credit for.
This has really made me think about how much we rely on intuition
Yeah.
when maybe a simpler, more objective approach would be better. But there's also that human element, right? Like the psychological reasons why our judgment goes off track.
Absolutely. There's so much research on why human prediction is so flawed.
Hmm.
Meehl and Dawes, the researchers we've been talking about,
Yeah.
they identified several key factors.
What are some of the biggest culprits? Like, why do our brains trip us up in this way?
One of the most basic reasons is inconsistency.
Okay.
Humans, even experts, aren't perfectly consistent in their judgments.
Hmm.
They might make different predictions based on the same information at different times,
Okay.
and contradict themselves.
So it's like we're not always playing by the same rules,
Right.
even when we're trying to be objective. But a formula, once it's set, will always give you the same output for the same input.
Exactly. That inconsistency in humans adds a lot of noise to the prediction,
Okay.
but models are completely consistent. You give them the same input, you'll get the same answer every time.
Consistency makes sense. What else messes with our judgment?
Another big one is lack of calibration.
Okay.
Experts often don't get or even seek out feedback on how accurate their judgments really are.
Right.
So they have very few opportunities to learn and improve over time.
Calibration. Can you remind me what that means in this context?
Sure, it's about how well someone's judgments match up with reality.
Okay.
Like if an expert always says something has a 70% chance of happening, and it actually happens about 70% of the time, then their judgment is well calibrated.
So it's a measure of how reliable their predictions are.
Right. And models, especially ones that are trained on lots of data, can be very well calibrated because their parameters are always being adjusted to match what's actually happening in the real world.
It's like they're constantly learning and fine-tuning based on feedback,
Right.
which is something we humans aren't always great at.
Exactly. That feedback loop is a major advantage for models. But even beyond consistency and calibration, we also have to deal with cognitive biases, those mental shortcuts that can distort our thinking.
Biases, the enemy of rational thought. We've talked about them before, but which ones are particularly troublesome when it comes to making predictions?
Well, overconfidence is a big one.
Okay.
Experts, especially experienced ones, tend to overestimate how accurate they are.
Yeah.
They think they've got a good handle on the situation,
Right.
which can lead to blind spots and missed opportunities to learn from mistakes.
So too much faith in our own abilities can actually hurt us. What else messes with our predictions?
The availability bias is another common one. That's our tendency to overestimate the likelihood of things that are easy to remember or that have happened recently.
Like if I just saw a scary news story about a plane crash, I might be more worried about flying, even though it's statistically still very safe.
Exactly. That vividness or recency makes the event feel more important in our minds,
Yeah.
even if it's not actually representative of the bigger picture. And then there's the illusion of control, that feeling that we have more influence over things than we actually do.
Like we're in the driver's seat, even when a lot of it is just luck or outside forces.
Right. All these biases, and there are tons more, can really distort expert judgments and make their predictions less accurate than those simple arithmetic models.
This is fascinating stuff, but I'm noticing we're running short on time.
Yeah.
Do we have time to wrap up this episode, or should we continue this in part 3?
Let's keep going and finish this discussion in the next part.
Yeah, it's amazing to think something as basic as like adding and multiplying can be so powerful,
It is.
especially compared to, all that experience in human intuition.
It really is, and it really highlights how important it is to understand
Mhm.
both the strengths and weaknesses of human judgment. You
Right.
know, knowing when to trust your gut and when to use more objective methods, it's crucial.
Absolutely. So as we wrap up this deep dive, what's the key takeaway you want listeners to remember from today?
I think the main thing is this. Simple math, particularly these arithmetic models, can be incredibly effective for making predictions.
Okay.
And they often do a better job than human experts, even in very complex fields.
For sure. But it's not about saying experts are useless, right?
Right.
They're still the ones gathering the data, coming up with ideas, and even developing those models in the first place.
Exactly. It's about using the right tool for the job.
Mm-hmm.
And sometimes that tool is a simple equation,
Yeah.
and that's okay.
This has been a real eye-opener. I hope our listeners are feeling inspired to think about how they make predictions in their own lives.
Yeah.
Any final words of wisdom before we sign off?
I would say pay attention to the predictions you make every day, big or small.
Okay.
Notice what factors you're considering, how you're weighing them,
Yeah.
and then how those predictions actually turn out.
You might be surprised at what you learn.
That's great advice. Start paying attention to those mental models you're already using,
Right.
and see if maybe a little simple math can help you make better decisions.
Exactly.
Thanks for joining us on this mathematical journey.
It's been a pleasure. Until next time.